You think you know how big the universe is. You don't. We measure human history in thousands of years. Our oldest civilizations, a few thousand more. Even the dinosaurs, gone 66 million years ago, feel almost recent when you zoom out far enough. But the universe? The universe has been around for 13 billion years. And that's not even close to the middle of the story. The universe has eras, distinct chapters, each one almost incomprehensibly different from the last. We're living in one of them right now. Stars burning, galaxies spinning, life existing. It feels permanent, but it isn't. In this video, we're going to walk through every era of the universe, from the first fraction of a second after the Big Bang, where the rules of physics were still being written, all the way to the last era, one which will exist far beyond our species. Before the Big Bang, even saying those words feels strange, because everything we know, space, time, matter, energy, all of it started at the Big Bang. So what does before even mean when time itself didn't exist yet? This is where science reaches its limit and where the most fascinating theories begin. One idea is that the universe came from nothing, not empty space, actual nothing. No space, no time, no laws of physics. And then, because of a random quantum fluctuation, something appeared. A point. Infinitely small, infinitely dense, and it exploded. But many physicists aren't satisfied with that answer, because nothing producing something still feels like it needs an explanation. Another theory suggests our universe is just one in an endless cycle. A previous universe existed, expanded, grew cold and dark, and then collapsed back in on itself. The collision of that collapse triggered our Big Bang. We didn't have a beginning. We had a reset. And then there's the multiverse idea, that our Big Bang was just one of countless others, that universes are constantly being born in a vast eternal sea of quantum chaos, each one with its own laws, its own physics, its own story. In this picture, our universe isn't special. It's just the one we happen to be inside. The honest answer is we don't know what came before. We may never know, but what we do know is what happened next. A fraction of a second after the beginning, everything changed. The Primordial Era. The first second, not the first minute, not the first hour. The first second after the Big Bang is where the entire story of the universe was written. The universe begins at a temperature so extreme, it's almost meaningless to describe. Millions of times hotter than the core of the sun. So hot that even atoms can't exist. Matter and antimatter are being created and destroyed constantly, colliding and annihilating each other in an endless storm of energy. And then something happens that nobody fully understands. Matter wins. For every billion particles of antimatter, there are 1,000,000,001 particles of matter. That tiny imbalance, 1 in a billion, is the reason everything you have ever seen exists. Stars, planets, life. All of it came from a rounding error at the start of time. As the universe expands, it cools. Within the first 3 minutes, protons and neutrons begin combining to form the first atomic nuclei, mostly hydrogen and helium. But the universe is still too hot and dense for electrons to attach. It's opaque, a wall of plasma so thick that light can't travel through it. The universe is blind to itself. Then, around 380,000 years after the Big Bang, something remarkable happens. The universe cools enough for electrons to finally bond with nuclei. Atoms form for the first time. And suddenly, light can travel freely. The universe becomes transparent. And for the first time, there is something to see. We can actually detect this moment today. It shows up as a faint glow across the entire sky. The cosmic microwave background radiation, the oldest light in existence. A snapshot of the universe at 380,000 years old, stretched and cooled by 13.8 billion years of expansion. But despite this release of light, the universe now enters its darkest chapter. No stars, no galaxies, just vast, cold clouds of hydrogen and helium drifting in the dark. This period is called the Cosmic Dark Ages. It lasts for around 150 million years, and then the first light is born. The Stelliferous Era. The first stars were nothing like our sun. They were enormous, hundreds of times more massive. So hot, they burned blue-white. And they didn't last long. Just a few million years before collapsing and exploding in the most violent events the universe had seen. But their deaths weren't wasted. Those first supernovae seeded the universe with the first heavy elements: carbon, oxygen, iron, the raw ingredients for everything that came after: planets, chemistry, and eventually life. Every atom in your body heavier than hydrogen was forged inside a dying star. We call this the Stelliferous Era, the age of stars, and we are living inside it right now. About 4.6 billion years ago, our sun ignites. Planets form around it. One of them develops oceans, then life, then us. We exist because this is the one window in the entire history of the universe where conditions are just right for life. But it has an expiry date. Our sun will eventually swell into a red giant, swallowing the inner planets. Earth becomes uninhabitable. The sun that gave us life will be the thing that ends it. Further into the future, the universe runs out of material to make new stars. One by one, the last red dwarfs slowly fade out. The lights of the Stelliferous Era switch off, and the universe enters a new chapter. The Degenerate Era. Imagine looking up at the night sky and seeing almost nothing. No bright stars, no galaxies blazing with light. Just a handful of dim, cooling embers scattered across an ocean of black. This is the Degenerate Era. The stars we know are gone. What remains are their corpses. White dwarfs, the collapsed cores of dead stars, slowly radiating their last heat into space. Brown dwarfs, objects that never had enough mass to ignite as stars in the first place. And neutron stars, the crushed remnants of massive stars that exploded long ago. These objects don't burn, they don't fuse, they just cool, slowly, over incomprehensible timescales. And then something happens that has never been observed, but is theorized by physicists. Protons begin to decay. Protons are the building blocks of atoms, of all matter. And if the theory is correct, given enough time they become unstable and fall apart, dissolving into lighter particles and radiation. This means that solid matter itself has an expiry date. Planets dissolve, the remains of stars dissolve. Everything made of atoms, slowly, particle by particle, comes apart. By the end of the Degenerate Era, almost nothing solid remains. The universe is darker and colder than anything we can meaningfully imagine. And the only things left standing are the universe's most extreme objects: black holes. The Black Hole Era. In the Black Hole Era, black holes are all that's left. No stars, no planets, no atoms. Just these ancient, massive objects warping space around them, drifting through an almost completely empty universe. They grow slowly, consuming whatever stray particles drift close enough. But there is almost nothing left to consume. The universe at this point is unimaginably sparse. The distance between objects is so vast that interactions become extraordinarily rare. Time passes on scales that make the current age of the universe look like a single heartbeat. But even black holes are not immortal. Stephen Hawking predicted that black holes slowly leak energy, a process now called Hawking radiation. At the edge of a black hole, pairs of particles spontaneously appear. One falls in, one escapes, and in doing so, it carries away a tiny amount of the black hole's mass. Tiny. Unimaginably tiny. The rate of evaporation for a large black hole is so slow, but given enough time, and there is plenty of time, even the largest black holes evaporate completely. The last black hole in the universe, a supermassive giant that has outlasted everything else, finally evaporates. There is a brief flash of radiation, and then nothing. No structure, no heat, no light. The universe enters its final era, the Dark Era. This is the end. Not an explosion, not a collapse, just an endless, silent, cold expanse of almost nothing. What remains in the Dark Era is almost too sparse to describe. A thin scattering of lone electrons and positrons drifting through space, so vast and empty that they may never encounter anything else. Occasional photons, light with wavelengths so long they carry almost no energy at all, pass through the void. There is no heat, no light worth speaking of, no structure of any kind. Entropy, the universe's tendency toward disorder, has reached its maximum. There is nothing left to change, nothing left to happen. Occasionally, an electron and a positron will drift close enough to briefly orbit each other, forming a ghostly structure called positronium. It doesn't last. They annihilate each other in a faint pulse of radiation. And then even those events stop. The universe becomes truly, completely still. This is called the heat death of the universe. Not heat, but the absence of it. A state of maximum entropy, where no energy can flow, no work can be done, and nothing can ever happen again. Whether this is truly the end, or just a pause before something new, we don't know. Some theories suggest that given infinite time, quantum fluctuations could trigger a new Big Bang, a new universe, a new story. But that is a question for a universe far beyond our own. We are 13.8 billion years into a story that has barely begun. The Stelliferous Era, our era, is just one chapter, and we exist in it for the briefest possible moment. But we are also the only part of the universe, as far as we know, that is aware of any of this. The universe doesn't know it's dying. We do. If you made it to the end, thank you. Videos like this take a long time to research, write, and put together. If you got something from it, subscribing means more than you know. It helps us keep making them.